Abstraction is important, but only when you understand the underlying implementation. In this video, we are going to deploy an API server end-to-end on AWS. And in the process, we are going to learn a lot of things about systems. Deployment of API and websites are very common practices, but we generally do not have the experience of designing the entire architecture. So in this video, you will learn about designing an architecture that will serve your purpose. Now it is very important to understand that deployment or any system is designed for a use case. In this video, I am going to design a system which works for a typical startup where you want to manage your cost and also want to control all the system and you want to make changes by hand. So I'm not going to use things like Docker container or any abstraction as such. So let's get started. The system which we are trying to create is an API server. API server is a server which serves JSON request and manages the state of user via databases. Now API server are very common. All the mobile application and reactive websites do work or leverage these APIs. So let's begin with the project. This project is a blogging API service which I had open source some time back and it has got very popular. This is a framework learning project where you learn about how to implement API services using Express.js and TypeScript. This is a project which we will leverage for deployment. Second thing that we will require is our servers. For that, I'm going to use AWS. AWS is a cloud hosting platform where you host your services like this API and Amazon provides the servers for you. So for this project, I'm going to create two servers. So this block, EC2, this one is your first server and this is your second server. So this project leverages two databases. One is your MongoDB and second is your Redis. MongoDB for persisting data so that you can query your data and alter that data based on various conditions. Redis is the in-memory cache. We are going to leverage in-memory cache so that our service become faster because this is in-memory and hence we can read and write very fastly compared to any database because of I/O operation. So two databases, Redis and MongoDB, are going to be part of our service. Now this EC2 is a service from AWS which allows us to create a Linux instance or Ubuntu instance on which you can deploy your services. So basically these are like the servers which you borrow or rent from the Amazon. Now on these EC2s you can deploy any program. So two programs, one MongoDB and Redis, we have already discussed. Other things that are required for this project is a Node service, and Node service will lie in your EC2, first EC2, right? So in a way, let's try to understand this, that first server will host your application, your APIs. Second server will have your database. Why have I separated database from your application server? This is because your application server will have a lot of requests and you'd want to scale these services horizontally or vertically as you require. And you'd want to have this data independent from these services. You can create more service like this API service. You can create another API service which might share the data from the same pool. So that is why I have separated MongoDB. Also, you would want to have a larger server and more privacy protection on the MongoDB instance. So on all the considerations, I have found it is very effective to have this database independently deployed from your application server. For the Redis, we are deploying it on the same service as application because this is going to help your application, and even if this data is lost, it will be recached. So for this project, I wanted to create a system which is simple, but at the same time, there is no abstraction. Throughout my career, I have always tried to remove the abstraction so that I can create a better abstraction. Abstractions are good. Abstraction means when details are hidden and you are mainly concerned with the use cases of that service or any system. This design is going to help you deploy your services in a way that you can control every aspect of it, which is very important for even learning or for a startup which is just developing. I have used similar system when I started my first company, and it did serve a few million developers very easily. Now, we have just discussed that we need two servers. First server is going to be responsible for your APIs, and second for your database. Now, let's talk about one very important element, that is Nginx. Nginx is a proxy server. A proxy server acts as a helper which first takes a request and then routes it to wherever that request could be served. So Nginx is very effective in our use case because we want to have multiple instances of our API service. So Nginx will act as a load balancer for us. And this load balancer is going to route our request on the first instance of our API service and also distribute to the second instance. Why do we want to have two instances? Because suppose you have to deploy the new changes. You want to first update the first service, so it will go down. But your service should not go down for the end user. So when you are deploying on one service, other service remains active. And even if one service fails, other service will be able to handle the request. So that is why we want to have a load balancer, and both these instances will be deployed on the same system. Now for a more evolved system, you can have this load balancer on a separate Linux instance or separate server as well. But we are trying to minimize our cost and increase our effectiveness. So Nginx is a proxy server which will act as a load balancer. On the EC2 instance, we will typically have a smaller system because that will incur cost. And we'd also want to safeguard it against some traffic spikes or system when it requires more memory temporarily. So there we are going to leverage swap. Swap does hamper some performance, but since we are optimizing for cost, it will not be that of a concern for us. So we'll create a swap and then we'll enable an access to EC2 via the SSH. And finally, we are going to have SSL deployed on the EC2 via Certbot. So this is the API layer, API service. Let me highlight the main aspects again. So we are going to have a server on EC2. It will have Redis and Nginx. Nginx will act as a load balancer, and there will be two API services, Node app 1 and Node app 2, and it will help to route the request on these two services. Finally, we will also be creating swap and have access to the server by SSH, and we are going to deploy SSL via Certbot. We'll see all the things in detail once we apply it. Now let's briefly talk about the database server. Most of the things of API server will also be applicable for EC2. For example, types of instance that we are going to create will be same. The security group would be same. Security group is a way to protect the access of your server via configuration on AWS. So there will be MongoDB service, and we are going to access our service by SSH. Now here, important thing, we will not open the port for MongoDB to the public, of course, because of the security reason. We will have an access to the MongoDB from our local system via a tunnel. We will see the SSH tunnel access to the MongoDB further. So this is the complete system which we are going to implement end to end, of course. And while we do so, I'm going to explain various aspects and consideration which we are going to take. Now, important part here, we are going to have a lot of commands that we are going to execute. So you don't have to remember the commands because I'm going to provide a link in the description that will have all the commands that I'm going to use in this application. You can go through that command and copy paste when you are going to deploy that. So this was about the architecture of our system. Now let's talk about the project. Link for the repository I have provided in the description as well. You can find this project on the After Academy GitHub. This project provides information about deployment using Docker. But we are not going to use Docker because we don't want to deploy it on one system. We are going to deploy it from scratch. So you can test and run this on your local system to understand more about the project. So basically it provides APIs which can be found on this document. So this document is about the APIs that has been implemented in the project. So for example, you can sign up, you can log in, then you can fetch your profile, write your blog, then publish your blog, and you will get the structure of the data. We are going to deploy this as a service on API subdomain for a domain of your choice. Here I have a domain which I have bought. I am going to leverage that for this project. You can also run this in the Postman. When you run it, it will just create this clone on your profile. I've already done so for myself. So this is the application on my desktop for Postman, and here you will find all the APIs and the examples. Great. Important part of this project is also to create an account on Amazon AWS. To create an account, you can go to the website of AWS and create an account. You will have to supply your payment information and finally it will be created. I have already created my account, so I'm going to sign up into the console. So once you are on the Amazon console, you will find various services. We are interested in the EC2. If it is not reflecting here, you can search EC2, and EC2 is virtual servers in the cloud. This is the service that we require. The first service that we are going to create is your MongoDB instance. And for FYI, the similar step will also work for any database. So when you search EC2, you have EC2 here. And let's open this EC2. Now first thing that you must decide where your server is going to be present. So there are various reasons which AWS provide for you to decide. For our purpose, I'm going to choose Singapore. To decide based on where your customer base is right now and where you want your service to be most closer. Now in the Singapore region, I have no instances running for the time being. So first thing that you would require after deciding the region is to create one server. So for creating a server, you have an option to launch an instance. So go to the launch instance. Give it a name. Let me call it MongoDB server. Now you must choose the OS on which you want to host your service. I've always used Ubuntu because I find it the most simpler and for me it is very familiar. So we are going to use Ubuntu. Now after choosing Ubuntu, we have to select the version of the Ubuntu. I typically want to have a more stable system for which most of the tools and the applications are optimized. So I'll go one generation before the current generation. This is my go-to strategy. So I'm going to use Ubuntu 24.04 LTS. LTS is important because this says that the long-term support is going to be provided. Okay. Now it says some of the service settings are going to be changed. This is fine. Now architecture. Architecture means the type of the CPU architecture on which the OS is going to run. I typically choose ARM nowadays because it is cheaper and it is more performant. Now this is important. Instance type. You'd want to select the instance based on the service that you are going to deploy and the throughput and the latency you want to have for your APIs. If your customer base is not so much, you'd want to have a smaller instance. If your customer base is larger and your data is going to grow very big in a small time, so you must choose an appropriate size of the instance. Here I want to maximize for my cost, so I'm going to choose T4G small. It will have 2 GB memory and 2 CPU cores. You can go even below like micro or nano, but I think small is well suited for a service like a database. Now only 2 GB RAM is there. That is why I'm going to use swap. Now if you see, there is a medium instance which has 4 GB RAM, but again the cost is going to be doubled, around doubled. So based on your budget, you can select the larger size as well, but I'm going to use T4G small. Now key pair, this is important. For the first time, you would want to create one key pair. Key pair is a key through which you can access your server through SSH. What type of key you want to create? Let me create the newer, more secure ED25519 and .pem because we are going to use OpenSSH. Okay, give it the name, call it admin key and then create. Now it will ask you to download it. Make sure to download and keep it safe because this is the one-time activity. If you lose it, you are not going to have access to your server once you are created through this key. So it is very important to make it safe, otherwise you will have to create new instance and new key. Let me check in my yes, I have admin key in my downloads. Now let's go further. You want to create a security group or select it. Let me create a security group. And the security group, it acts like a firewall. It means that whenever somebody is trying to access your server from outside, then it will decide that which port or IP can be accessed from outside. So in the security group, what do I want to allow? This is a MongoDB, so I want to have an access to the service through my laptop. So I want to allow the SSH traffic, but from anywhere. No, this is not what I recommend. I want my IP address of my system that has been provided by my network service provider to be the only IP from which this service could be accessed, the most secure option. Now there are two things. If you are accessing it from the office, if it has the static IP, then it's fine. It is not going to change. But your IP might change in 2-3 days. Then you will come and update your IP address. Otherwise, you won't be able to access it, right? Do I want other traffics like HTTPS and HTTP not on the MongoDB? This is fine. Now storage. Storage, how much storage I want? I will start with a 20 GB for my database. So there are various options. I will use the SSD GP3. Now file system, let's not choose any file system. This will be the minimum configuration that would require for your database service. Finally, how many instances you want to launch? 1. Fine. So let me verify. I will be having a Ubuntu instance of version 24.04 on ARM 64. Server size is T4G. A new security group will be created and a storage volume of 20 GB. I'm satisfied with the configuration, so I'm going to launch this instance. Now the instance has been launched. Let me go and view all the instances. So here you see you have MongoDB server and it is running and all the details are here. Now this service could be accessed by our local system because IP address has been provided. Let me show you one important thing here. When you select this instance, you have information about your public IP address and the private IP address. Private IP address is the IP address within the network of the Amazon, and the public IP is the IP address which is exposed for the internet. Here there is security, the security group that we had created. Okay, there's security group. Once we go and see, the security group has only one configuration. It says port 22 is open from the IP address. You can edit this and add more rules, like you want to open up, let's say MySQL, Postgres, or other ports. To which IP address you can decide. For our case, this is not necessary. Let me go back to the EC2 dashboard and the instances. Now one thing that I want to do here is to make this public IP fixed. Now this IP address can change when you reboot your server. So to make it frozen, I would want to use something which is called elastic IP. Why do I want to have an elastic IP? Elastic IP is the IP address which does not change, because this IP I am going to leverage on various other services. So if the IP address of this server changes, then everywhere I have to go and then update this IP address, which I don't want. So if I go into network and security, there is an option called elastic IPs. I'm going to allocate elastic IP address. So from the pool, yes, I want from the pool, and all the options are fine, just allocate it. Now this IP address has been allocated. Let me write a name, MongoDB server. Now let me click on this IP address, and now I'm going to associate this elastic IP address. Association means this IP address will be now mapped to any server. So any instance, yes. What instance? Here is one server, MongoDB server, which is running. I'm going to choose the instance. Allow the elastic IP address to be reassociated. No, I don't want this. Associate. So this IP address is now the new IP address of your server. Now this IP address has changed to the elastic IP. So this is now not going to change even if you reboot or restart your server. Now let's do one more thing. Go to the volume, elastic block storage. Go to the volume. You have one volume. Just rename it. This helps to track what volumes are associated with which instance. Let me call it MongoDB storage. Okay. So that whenever I'm trying to delete it or create a new instance, I would know that what is this volume attached to what instance. Fine. So now we have created our first server on which we are going to deploy the MongoDB. Now next step is to access this server on our local system so that we can run various commands. For doing it, we have to open our terminal. Let me open the terminal of my choice, that is Alacrity, and here let me go to the downloads. I am going to the downloads because this is for the sake of this video. You want to store it on a more safer and secure location. List down all the files. So admin.adminkey.pem is the file that we want to have. Now let's do one thing. For SSH to use admin key.pem, it must be protected. Protected means it has to be given certain permissions. So for that, we will provide a permission for read only, so that SSH consider it more secure, and hence it will allow these keys to be transferred over the network. So chmod 400 for the read permission, and for this PEM file. Let me do one thing before. Let me rename it to something which is not having a space. Yes. Now let's provide appropriate permission to this key. Now let's check the permission by making a SSH request. To make the SSH request, you have to use SSH and then supply the key. Supplying the key, you have to give -i, and the key is admin key.pem, and then you have to give the credential or the location of the server. Now, when you create an Ubuntu server, a default username, that is Ubuntu, is created on it. So the command is Ubuntu, the username, @ the IP address. What is the IP address? Let me go to the EC2 and the IP address. This is the IP address, public IP address, @ public IP address. Now once I hit enter, now it is asking that should I trust this fingerprint or not? Yes. Now I am inside my server. Now one important thing that you must understand for Mac users, when you are in the security group and you supply the my IP address, you must turn off the private relay if you are using the iCloud service, because the IP address provided by the private relay tries to hide your IP address. Hence you won't be able to access the server, because your IP address in the security group will be different. So make sure that you turn that off. Also verify it by finding your IP address from Google. From where is my IP, you can find the IP address. This should match the IP address that has been supplied here. Okay. Now we are inside our server. That is great. Let's see the system configuration. For that, you have to type a command htop. This shows all the memory that is available, that is 2 GB here. So 1.79 GB is available, and there are 2 cores. Now all the processes which are executing you can find below. So this is very good tool to monitor what's happening inside your system. So far we were able to create a server and securely access the server using SSH, and now we can run various commands to install softwares through our terminal by using our SSH. First thing that I would want to do is increase my RAM capacity by using swap. Of course, swap is something which is last resort where I want to optimize the cost. I have found that it does not degrade my service as much as I would want to optimize the cost. So this is fine. So first let's see what is a swap that is available. For that I have to type sudo swap on -- show. There is no swap available right now, so we have to create it. Sudo fallocate -l. How much I want my swap to be? Let's make it 4 GB. 4G capital, and then provide a file path, that is swap file. Okay. Then let's check the file size. LH my path to the file. Now it says there is a file which has a permission of read write to the root, and it is of 4 GB size. Now let's restrict the permission to only the read write to the root. For that we have to write sudo again chmod 600 permission to our swap file. Okay, and then again check. Now only root can read and write, no other can access this file. Now let's make a swap. Sudo mk swap and the file path. Okay, it is saying that it is creating the swap file. Now let's enable the swap file to be used by the system immediately. For that we have to write sudo swap on and the file swap file. Now this must be available. Let me again see the swap. Now it's saying that there is a swap file of 4 GB size, and this is now being used as a swap. Now we have to persist this swap so that whenever we are trying to reboot, this swap file is again mounted and utilized as a swap memory. For that we have to back this up. Any changes that we are doing, we must back it up. Copy this configuration, which is in the etc f stab to etc f stab dot bak. Why we are doing that? Because we are going to change this file, and by accident if we do some mistake, we'll have a backup. Okay, now let's append this entry in the swap file. So how to do that? We can echo it what swap file that we have created, none swap sw 00 is a string inside sudo t minus a etc slash f stab. Okay, now it has written inside the etc f stab. Let's read it. Vi etc f stab. Now if I see the content, it has written f swap file non swap sw00. So now this is saved in the file of fstab. So whenever system is going to reboot, it is going to reload this file as a swap space. Now let's check htop. Now in the htop you can see that there is a swap which is a 4 GB size. So we have successfully created our swap and persisted that swap file against the reboot, and now whenever there is more pressure on the RAM, this swap file will be used. Now next step is to install the MongoDB. To install the MongoDB, let's first check the name of the operating system, because the release of the MongoDB has to be mapped with the different operating system. Now we already know that we have created 24.04 version, but to be sure, let's check the name of our operating system, lsb and release minus a. Now it says the code name is noble and the release version is 24.04, Ubuntu 24.0404. So this is fine. Now we exactly have the version of the operating system. Just we verified it. Now let's refresh the package list and apply all the available updates. It is advisable to do all the updates before you go on to do more things on your system. For that, let's write sudo apt update, and at the same time also run sudo apt upgrade. and don't have to ask. It will take some time for your system to update. Now all the packages are updated. We would need certain tools to verify the binaries of Mongo, and for that you have to write sudo apt install -y curl gnu pg ca certificates. Okay, typo. No, GNU CA certificates are installed. Now we have to import the signing key for the MongoDB. I'm going to copy paste this. So I'm making a curl request to the MongoDB repository where we have this signature, and then we are going to get the list from where we are going to install our MongoDB. So we have added our MongoDB repository list in our apt, and now we are going to update our list. Sudo apt update. Now we see MongoDB Ubuntu is now added in our list of packages. Let's check the version that is available in the package list. Apt cache medicine MongoDB -org. It says on the list of packages we have different versions. 8.3.4 is the latest version for the ARM64 for our operating system. So we are going to use the latest version for our case. Now let's install our MongoDB and various tools which we will need for our server. I'm going to copy paste. You will find all these commands in the link of the description. So here I'm saying that sudo apt install and take my permission MongoDB org version 2.3.4, which we found the latest version on the package list, database, server, MongoSH, Mongos and tools. All these packages I'm going to install. Now let's reload the systemd, which is the service manager on the Ubuntu, so that it sees the MongoDB which has been now downloaded. Sudo system control, then daemon reload, DAEMON. Now let's start the MongoDB server. For that, let's write sudo system control start MongoD. Service has been started. Let me enable this service as well. Now enabling this service means that whenever system is going to restart, this service of MongoDB will also restart. Now let's see the status of the service. Now you can see the status. The service is running and it has executed few commands. Now open the shell of MongoDB so that we can verify and create some users there. For that we have to write mongo sh. Now it has connected to the MongoDB service here. Let's write db.version 8.3.4. Great. Now we have installed the MongoDB on our EC2 instance, and we have also enabled the service, and after enabling service we can have access to the MongoDB and run some queries. And now let's change some configuration of MongoDB so that it becomes secure and as per our use cases in the sudo, because they are installed as a admin /etc/mongod.conf. This file holds the configuration for the MongoDB. Here let's enable insert mode first, wired tiger, and use spaces, and then engine config, and here cache size GB 2.5. This is important because your server is not very capable or big, it is small instance, so you don't want to have a large cache size. So that is why we have reduced it to 0.5. We have to enable our security so that we can access our MongoDB using password. In the security, let's write authorization enabled. Yes, and then let me save it. We will reload our configuration again by restarting the MongoDB. We have done a couple of configuration changes for the MongoDB so that it becomes secure and efficient for your system. Now let's create some users in the MongoDB so that we can leverage those to connect to different databases. Let's open the MongoDB shell command, mongo sh. Now we are inside our MongoDB. Let me use the database admin, use admin. Now we are inside the admin database. In the admin database, we are going to create a user. So let me copy paste. So I have written db.createUser, and inside the parameter we have passed username is admin, password is changed it. You put the password as you find fit, and the roles will be user admin any database and on the db admin. So let me create this. Okay. Now let's exit this. Now let's use the new created user to access our database. Mongo sh user admin, take up the password and authentication database is admin. Asking for password, change it. So now I am able to access my MongoDB using the new user admin and the password that we have provided. Let's do one more thing. Let's provide a role to our admin that will be the root role. For that, let's write, first we have to go to the admin database, and there we have to write db.grant roles to user. Here the username is admin and the role db.grant roles to user. User is admin and role will be your root and db is your admin. Close the bracket. Now it is important to create a user specific to a database so that you can control the access, and in order to protect the data you must create a user for specific role. On our MongoDB that will hold the data for our API server, we will call it production DB, and the prod DB will create another user that will have the write and read permission. It won't have permission to do any changes to the system or other databases. So for that, let's create a prod.db, use prod.db. Now we are in this new database which is going to be created. Here I'm going to create a user, the same command that we used for our admin. We're going to use it for user. So I'm going to create a user and call the user as prod.db user, and we'll supply the password, change it for purpose of this video, and the role will be read and write on the database prod.db. Okay, let me close this now. Now we would want to have access to this database using your local system. So we are going to use a GUI tool which is called Compass, provided by the official MongoDB. You can download the MongoDB Compass from the official MongoDB website for your operating system, and once you download it, you can open it. Here, in order to connect to your service on EC2, you have to create a new connection, and in the new connection, go to the advanced connection option and use proxy or SSH. We have not opened the port for our IP or any other IP because we want to directly connect it with the SSH with the identity file. Okay. Now here you have to provide the host name, which will be the IP address. The IP address is in the EC2, and provide the IP address here. SSH port 22, fine. Username is Ubuntu, and the file through which SSH will connect in the downloads, admin key. There is no paraphrase here, so let's save and connect. Okay, since we have enabled our authentication, we'll also have to provide the authentication here. In the advanced authentication, username was your admin that we had created earlier, password was change it, and the database admin. Now it is connected to our database, and you can see that you have admin database here and other things are also there. We connected with the admin. Let's connect with our production DB user. Let me duplicate this connection and call it prod DB, and here in the authentication, let's apply the username. Username was prod DB user, password was changed it, and the database was prod DB. Now you can see the prod DB is connected, and there is nothing here because we have just created the database. So either we can connect by the admin. Let me rename this. Or we can connect it via a user for the prod.db. Prod.db user can only make changes to the prod.db and nothing else. Admin can do changes to any database. Now we have set up our MongoDB by creating an admin and a user for the prod.db. And we are able to access our database through our local machine using SSH. So this ends the configuration part of the MongoDB. And now let's move to the part of creating our application server. We have successfully completed our setup of MongoDB server on EC2. Now let's move to the main part of deploying our services on the API server on EC2. most of the things that we have done on the MongoDB part would be utilized for creating our server, and setup of swap and SSH would be the same for us. So we'll quickly move through and create another server for our API. Now for that, let's go to the dashboard and go to the launch instance again. Call it API server. Again, the Ubuntu instance and the version 24. Confirm. ARM. Confirm. Then T4G small. This is fine. Key value pair, I'm going to utilize the same which we had created for our database, so that through that single key we can now have access to multiple servers. And create a security group. Yes, create a new security group. Allow SSH not from everywhere, from only my IP address. Allow HTTPS and HTTP. Yes, this I want. Why? Because this is going to be API server, and any person on internet or any service on the internet can call API. And storage is 8 GB. Let's also create 20 GB. And let's verify. This is fine. Launch the instance. Now, before you can access the instance through the terminal, you might have to wait until the instance state here. And now let's do elastic IP again. Elastic IP, allocate elastic IP. It's fine. Allocate it. And here, let's rename this API server. And then save it. Now, select this IP address and associate this elastic IP and to the instance. Which instance? API server. Then associate this. Now this IP address is now associated. Just our step where we name our instance storage. Let's do the same here. API server. Yes. So that we can always identify the instances, volumes. So renaming things are very important. Now let's check the instance. This instance has IP address, public IP address. This is the public IP address. So we'll connect it again. Let's go to the downloads where my key lies, and then SSH -I and the key. It is admin, and then user is again default username is Ubuntu @IP address. Now this is our public IP. Let's fix this. Yes. Now we have got access to our server. Let's check the configuration. Again, 2 cores and about 2 GB of RAM, and there is no swap. Let's create the swap quickly. 4 GB swap. Permission to the swap. Format the swap and enable the swap. And let's see the swap. Yes, and then let's back up a configuration file and then append into the configuration so that it becomes permanent. Let me check swap again. Yes, now we have 4 GB of swap now available for us. The swap is set up, the same step that we did for the MongoDB. Now, on this application server, first thing we would do after swap is to install our Redis server. So for Redis server, let me update my apt list sudo apt update. Now let's install our Redis server. Sudo apt install Redis server and take my permission. After that, let's enable the service. Sudo systemctl enable Redis server. Okay. After that, let's check the status of our server service. Yes, it is running and it is executing commands. We'll have to do certain configuration changes again, just like MongoDB, so that we can make it secure. For that, we have to run sudo vi etc redis and then redis config redis.conf. This is the configuration file. Here we will have to make changes. For example, I will have to find the password. So you have to scroll down to security where you have this option require pass. So let's enable this, and the password, you set the password of your choice. Let me change it. Okay, so we have set the password for our Redis in the configuration. Now we'll have to restart our Redis service. Sudo system control restart Redis. Okay, let me check it. Redis CLI is password, which is change it ping. I'm getting pong, so it means I'm able to use my password and I'm able to talk to the Redis server. Let's check the info. Redis CLI password, change it info. Redis CLI info. This is all the information about the Redis server. Interestingly, if I don't supply the password, let's see what happens. Authentication is required. Great. So we have now set up our Redis server and set a password for it. Now next step would be to set our Nginx. Nginx is a proxy server, as we talked about. First we'll have to install the Nginx. Let me clear this. Then let me first update all the packages again. Sudo apt update and sudo apt upgrade. Now our system is updated and upgraded, and let's install the Nginx. Sudo apt install Nginx, take the permission. Now we have to start the service of Nginx again. Sudo system control is a way that manages your services on your system. Sudo system control start Nginx. Let's check the status. It's running. So we have installed Nginx and now it is running. It will be accessible on the port 80, right? So if we check our API, let me run the Chrome. Let me supply the IP address of the EC2 instance. If I ping the IP address, Nginx is available. So now Nginx I am able to access through the IP address. We will first define a directory where we are going to access everything. For us, it will be our var ww. This is the way I do it. You can select the directory of your choice. Cd var ww. This is the place where I keep all the projects. Now let's do one thing. Let's create a page which is a prettier version than this Nginx. So we have to go to the HTML, and here we have to create a file. Let's call it vi502.html. Now you can create the HTML file of your type using any LLM tool to get a very highly polished page. I have already done and generated a page for myself, which I'm going to use here. Let me show you how does it look. .html, the downloads. Let me go to the downloads. Here, let me open this in the Chrome. So this is how this HTML page looks like, and this I have generated through Claude. You can generate your own 502. 502 is basically when there is no service and Nginx will serve this page. We'll move ahead. This 502, just note it down. We are going to use it later. Now we have our Nginx and the Redis configured for our server. Let's get our project repo. For doing the project repo, first we will have to access the GitHub through your credential. In order to do so, you have to use SSH so that you can securely access the repository which you will pull on your server and then will run and execute. So whenever you push something on your repository, you can pull it again and that will execute. Now first let's generate a key on your server, and then you will use that key to configure your GitHub. So to create this, you have to use SSH keygen, and the type will be ed25519, and write a comment. Comment is EC2 token file. Yes, this will be the default file path. Home ubuntu.ssh. Paraphrase, I would keep it empty. So now you have got your fingerprint SSH-A265. You'll require this. Now open up your GitHub settings. So here, go to your profile, and then go to settings, then SSH and GPG keys. Here add a SSH key. Give the title API EC2. I'll write example server and the key. Now we also have to do one more thing. We have to add this generated key into your agent, and for that let's do eval SSH agent -s. This is going to add your key into the SSH agent. Okay, the agent now has this key. Then add this to the agent. SSH add in the location of the key .ssh/id. So this key is now added. We'll have to copy the public key and then save it to the GitHub. So for that, .public. This public key I'll have to use. Here it says it should start with this value SSH, and this is your key. Add the key here. Now the key is added. Let's check this key. To check the key, let's write SSH minus capital T git @ github.com. Hi Janishar, you have successfully authenticated. So now we have configured our GitHub SSH and we can clone our repository using SSH on our server and push and pull without needing any password or username. So let's go to the repository and then clone the repository which we had discussed. SSH, this one you have to use. First go to www cd where www here ls. Let's clear first. Now let's clone our repository here. Git clone. It says permission denied. So we'll have to provide the permission of www folder to our Ubuntu user. Sudo crown -r Ubuntu user to the folder var www. Now let's clone again. This time it is cloning because var www is under the ownership of the root, and here we want to clone it via the key which is saved in the Ubuntu users domain. Hence we have to provide the permission of var www to the Ubuntu to make read and write. Now let's check. Yes, I have got the project here. Let's rename. It's big name which would not be good for us. It's called API. API is 1. So we have got API is 1. Let's go into the project cd API is 1 ls -a. Let's see all the folders. We'll have to install Node.js for our project to run, and for the Node.js we are going to have the installation of nvm, which is a manager for Node version. To install the nvm we have to go to nvm download nvm, and we want on the Linux machine. So here you can find there is a curl request which will get the download script for nvm. We're going to use that. Curl, install it, update all the variables stored in the terminal, source bash rc, and now let's check the nvm version. Now let's use nvm to install the node. Nvm install LTS version of the node. It is installing node 24.18. Okay, and let's nvm use LTS. Now this will be the node version, default node version. Now let's also add the alias nvm alias default node. Now by node it will point to the version 24. Let's check the version. Node -v is 24. Also check npm -v, it is 11. So using the nvm we have installed the node and the npm. Let's also check which node. It is giving the path for the node. Let's go back. Let's clear this and go back and see our project. Here we have to do install, npm install. Okay, and let's edit our env file. When we install it, env file must have been created, because in the post install script this is written in the project. And here we have to change db host because we are not using Docker. We are going to use our MongoDB server. So IP address of the MongoDB has to be used, but which IP? Public IP? No, we want to use the private IP of the MongoDB because it is not exposed to the internet. We are going to talk the services within the AWS services, MongoDB server. So this is MongoDB server. Let me see again. This is the MongoDB server. In the instance ID, we have this private IP address. We are going to use this private IP address. And the port is fine. And also for the Redis, we'll have to use the local host. So we have to use localhost. Okay, and save it. We have modified the environment file. Let's do one more thing. Let's get out of this directory. Let me create one more copy of this API. Why? Because we want to have two instances of our application server. So first application server instance will be APIs 1, second will be APIs 2. Copy -r recursively APIs 1 to API 2. Now let's check this. Go to APIs 1 again, and here let's run a build script. Check everything is installed or not. The build is successful. It means everything has been installed successfully. Now we have set up our GitHub. We have created two instances of our project, API project. Next step is to run this as a service. We'll have to now create a service for both of these two APIs. Service is required because we want to execute in the background, and second, we want to run these services whenever the server starts, so that we don't have to manually go and start the services. So for that, we'll have to go to etc systemd system. Here we can see there are various services like Redis is there. We have to create our own service. This is systemd, which is a service manager which manages different services, how they are executing, and it is responsible for starting and stopping those services. This place we are going to create sudo vi apis1.service file. In this service file, we are going to write certain script which will enable our APIs to run. For that, I'm going to copy paste here. This is our first service. So here we are going to write the description. This is API 1 service, and the working directory we will go to the var www API 1. So it will first go to the APIs 1 directory, and then it will put in the path variable the node version which we have just installed via nvm, the complete path of it, and after that it will run npm. So npm will be found in this bin folder. When I run npm from here, this will resolve to this bin because I am exporting the path while I write this bash command. Now this will run at the port 3000, and I will run as a user Ubuntu, and in the group Ubuntu this script will be executed. Now let's save this. So one service is now created. We want two API services. So let's copy and create another version of it. Let's call it APIs 2 service. Okay, let's run with sudo. Now sudo vi APIs 2 this time, and here I'm going to run as API 2 as a description, and it will go into the working directory that will APIs 2, and it will run on the port 3001. One application can only run on one port. That is why we have to provide another port here. Let me save it. So I have created two services. Let me enable those services so that it will be managed by systemd. Then sudo systemd ctl enable apis1 dot service, and also do the same for api2 dot service. Now let me execute this service. Sudo system control start api1. I don't have to write service now. I have run apis1. Let's check the status. Now it says that it has started to run, but Mongo's connection has failed. So MongoDB has not been connected. So what we did, we provided the IP address, the private IP address of the MongoDB in the environment file, but here it will go through the security group. So in the database EC2 instance, in the security group, we will have to enable other services to even talk to the other services through private APIs. So let me go to EC2, go to the instances. In here, this MongoDB server. Let's go to the security group of the MongoDB. And in the MongoDB, let me edit the inbound rule, add one more rule. So here in the security group of my MongoDB server, let's add a custom TCP 27017, the port of the MongoDB. In the custom, I want it to, I'll provide the access to the security group launch wizard 2, and the preview changes, confirm it. So now I will have access to the MongoDB from the server. Now if you see the status of the application, it says that it is not able to connect to the IP address of the MongoDB. We have just put the MongoDB local IP address, and we have provided the security group access to the MongoDB into the security group of the application server. So we have to bind the local IP address in the MongoDB. By default, it is binded to the local host. We have to bind it to the local IP address as well. So let's go to the MongoDB server. In here, open the configuration, sudo vi etc mongod.conf file. Here we see that in the bind IP, it is binded to the local host. So it is only accessible by the operating system in the server. So it cannot be accessed on the local infrastructure. So for that, we have to assign or bind the IP address to its local IP address. So first of all, we have to know the IP address. Let's get the IP address of this server, local IP address, and that IP address will be found by host name -i. This is the IP address of the server running the MongoDB. Now let's try to add this. In the configuration of MongoDB, now it will be binded to the IP address which is visible to the local system as well. Now we have to restart our MongoDB server. Sudo system control restart MongoDB. Let's check the status again. Now it says that it is running, and hence our service configuration is fine. Now let's try to again ping the IP address on port 2707 from the API server and check if the port is open for the API server. To do so, we have to write nc -v and the IP address on the port 27017. Yes, it is connecting to the port 27017. Now our application build should succeed. Let's check again. Let me restart. System control. Restart. Our API is 1. Let's check the status. It is building up. Let's wait for some time. Now let's ping and check if it is connecting. The command is nc-v localhost on the port 3000. Yes, it is connecting. So port 3000 is up. Let's connect to port 3001. It is refused because we have not executed our command for 3001. Now let's restart our service at 3001 port API, and it will be sudo system control restart APIs 2. Let's check the status. It is building. Now it has started to run. Let me check nc-v localhost port 3001. So I am able to ping both the servers at 3000 and 3001. Both instances are running. So my server are now ready, and I have two instances of my application. One is attached to 3000 port and another one is 3001 port. Now I can expose both of these services through Nginx to the outside world. For that, we'll have to configure sites in the Nginx. Let me show you. Let me clear this up. Now in Nginx, in order to make the request that comes to the Nginx at the port 80 or 443 to fall on one of these ports, you have to create sites. So we have to go first to cd/dc Nginx site available. So here we write a configuration file which maps how the requests are going to be handled. So the API that I'm going to use for this service will be API dot. I have a domain name which I have bought from GoDaddy. You can supply your own domain name which you must have bought. That is aibackuslab.com. So subdomain API and this domain name. I want my service to be configured as whenever there is a call on api.aibackuslab.com through HTTP or HTTPS, I want the Nginx to route these to either of one of the application 1 or application 2 by load balancing. So first I have to create a configuration file. Let me write sudo vi and the file name as the complete URL. Here I need to create configuration which I am copy pasting. You will find it in the link provided in the description section. Now here what I have created, I've created an upstream. I'm going to call it API_server, and here I am going to create a server which will map the local host IP address, that is your 127.0.0.1 on the port 3000. The first server will listen to port 3000, and the more configuration max fail, that is 3 times it will fail and then fall back to another server, and for fail timeout is 10 seconds. After 10 seconds it will switch to the next server. And I'm also going to add another server, and that will point to the local IP address and your local host on the port 3001. So I have created an API server which maps to two servers listening at two different ports. Okay, so whenever there will be an API call, so Nginx will either pass it to the port 3000 or 3001 in the round robin fashion. And in the server block, I'm going to provide the server name, which will map to the domain name from which the call will be made to the Nginx. Server name will be api.airbackerslab.com. Here, more configuration, the maximum body size which can be sent as JSON will be 10 megabytes. If there is an error page, it will go to the location of custom errors and then 502.html. You remember we have created 502 HTML. Whenever service is not available, it will go to this page rather than showing the Nginx default messages. And I have defined the custom error location, which will be an alias of var www.html, the folder that we have just seen earlier in the video. And finally, we have defined the location. Whenever there will be a call, it will pass this request to HTTP API server, which we have defined above, and furthermore configuration which will add and append headers which we can get into the API server. So this is a load balancer setup using Nginx. Let me save it. Now once we have created configuration in sites available, we have to enable it, right? Enabling means it will be now available for outside world to be processed. We have to create a symbolic link of this configuration into sites enabled. Let me show you. So the command for that is sudo ln -s symbolic link, and that will be site etc nginx sites available, this one, and file name api.abacuslab.com, and it will be mapped as a symbolic link to site enabled, and the name of the file would be again api.abacuslab.com. Let's go to the location of site enabled. Now you can see there is api.abacuslab.com. It is colored and it's a symbolic link. If we read this file, it will show up the same content. So we have created configuration file that would act as a load balancer. Whenever there will be a call to api.abacuslab.com, it will either be routed to one of the application services. Now after this, we must reload Nginx with this new configuration, sudo nginx -t. So configuration was loaded and it was successful. Then we must restart our Nginx, sudo system control reload Nginx. Now let's try to hit the API again. api.abacuslab.com. It is not accessible. Why? Because right now this api.abacuslab.com is configured in a DNS, and we haven't pointed the DNS to this IP of this server. For that, we have to go to the hostname provider, which in my case is GoDaddy, and go to the DNS management in the bot domain name. Here I need to create a record because it is going to point to an IP address of the machine, and it will point to the API dot and the domain name. IP address of my server, I need the public IP address, which I will get from here. API server, this is public IP address. This I'm going to provide here and save it. Now whenever there will be a call on api.abacuslab.com, GoDaddy, the DNS provider, is going to route it to IP address that we have provided. Once it reaches the IP address, Nginx will get the response and it will read that it is from the domain api.abacuslab.com, and hence it will then move those requests to either one of the application running on the port 3000 or 3001, and it will be served. Let's check again. It takes some time for update to take place. Yes. When I call api.abacuslab.com, I'm getting the response from my API that this requires an API key as well. So now this domain name is mapping to the service. Now in this response, you will see that it is not secure. Why? Because it is through the HTTP connection. I want the HTTPS connection to be enabled. For that, I will need an SSL certificate, and to get the SSL certificate for free, we are going to leverage Certbot. So we have to install the Certbot, sudo apt install -y, permission is granted, Certbot, and Python 3 Certbot for Nginx. Now our Certbot is installed. We are going to acquire a certificate for our API endpoint. For that, we have to write sudo certbot. I need for Nginx configuration, and the domain will be api.abacuslab.com. So this Certbot, it is asking email address ali@afteracademy.com. So whenever there is renewal or any information, it will send a mail to you. Yes, I do agree the terms. Yes. Certbot is an authority of providing certificate for free, and after 3 months it renews the certificate automatically, and it also sends an email. And certificate has been deployed. If I go and see the Abacus Lab sudo vi or configuration file, we will see that it has added SSL configuration by Certbot. So it went on to download the certificate and also attach those certificate configuration to your configuration file. Now let's check with the HTTP. Now there is no not secure warning, and if I go and see the connection is secure, and if I see the certificate, it says certificate is valid, issued by Let's Encrypt. So we have successfully attached an SSL certificate which enables HTTPS to your API endpoint. So far, we have deployed our API service on a domain endpoint, that is api.abacuslab.com, and associated SSL with that. We will have to set up our backend database so that our service can start operating with the default data that we would require. If you see in the repository, we have something called add-ons here, and in the add-ons there is init mongo. When you run the Docker, this is executed automatically, but since we are not using Docker, we'll have to create these collection for our system to start working. So there we would require an API key collection and roles connections, and rest will be created by the application server itself and one super user in the users collection. Now let's see what it says. The API key collection must have these fields: key, permissions, collection, comments, etc. And then let's connect to our prod.db. Now prod.db is connected. API key, this is the schema creation when your application starts running. So then schema creates these collections. In the API key, let's open the shell. In place of find, I will insert 1, and here I'll supply this object. Execute. Now it is inserted. Let's do the insertion on the roles as well. It is inserted. Now let's also do for the super user, admin user. Perfect. So if I go and now see, a default API key is created. In the roles, I have 4 roles defined and a user is created. Now if I hit login now, but before that we have to go into the environment. This is the Postman file that you will find in the documentation link that we saw earlier. The base URL, we have to now hit https api.aibackuslab.com. API keys, this is what we have inserted. Admin and password is fine. Then just save it, and now let's call the login. In the body, let's use the admin email and the password. Yes, now I'm able to log into my system. I've got the access token. I'll add this access token in the access token environment key. Profile private, I'm able to fetch my private profile through the access token now. So this completes the deployment of the API service on a custom domain. You can take this example to deploy any services, your website, your any bot, or any service that you can imagine. Now, one more thing here. Suppose you have to update any API changes that you have done in the code. Simply you have to go to the directory where you have kept the project. Go to the APIs 1 and just write git pull. If there is any change, it will push, and do the same in the APIs 2 as well. APIs 2 git pull. Now you will get the changes from your repository to both of these directory. The point of keeping service of 2 part is that suppose you want to update and you don't want your service to be down while you are updating. So you will first pull all the changes into the API 1 and then restart sudo system control restart API 1, and when you restart this, all the changes that you have done will go into the APIs 1, and once it is live, then you can restart APIs 2. This way your service will never be down. So that was the point of putting load balancer. So let's recap what we have learned so far. We learned how to host our project on the GitHub. We set up 2 EC2 server instances on AWS, configured one for the MongoDB, another one for our API services, which also uses Redis. And in Nginx, we created 2 instances of our application server, and Nginx act as the load balancer. So this completes this tutorial, which helps you deploy any service in the cloud, AWS in our case, and you can leverage this to deploy any personal project or project of your company. You will have total control of the deployment, and it will be very cost effective. So I hope you must have learned something meaningful out of it, and if you have done, please subscribe and like this video. It will motivate us to create more such videos in future. Thank you.